Okay, so in this problem, we're going to solve the following quadratic equation using U substitution. Now make sure you're always following directions, so the directions indicate to use substitution. And I want you to use the variable U. So we have this quadratic equation. Now remember, if there was no set directions in terms of how to solve this equation, then you could square this expression, this binomial, 3x minus 4, multiply by 4, then distribute the 15, and then subtract 4. And when you do all that, you're going to end up with this equation here. But that's not what the directions indicate. All right, so remember, um, if these directions were not here, then you could do this. You could square this binomial. You'll get this trinomial here, this quadratic trinomial. Then you would multiply by 4. Then you multiply this expression by 15, and then subtract 4, and you do all the mathematical operations here, and you get this quadratic equation. But that is not what you're asked to do. So always follow directions. So the direction says use substitution. Now the idea behind that, remember, in class we discussed that if you look at this quadratic equation here, you'll notice that this expression 3x minus 4 is being squared, and it's also located here and is being raised to that first power. And so what you may want to do in terms of substitution is let u equal that binomial, that linear expression that you see. So you're going to say this now. You're going to say let u equal 3x minus 4. Okay? And now wherever you see that expression 3x minus 4, you're going to substitute the variable u now. And so we get 4 u squared, see this became this now, plus 15 u minus 4 equals 0. And now what you have is a quadratic equation that is familiar to what you've been dealing with. So you have one variable, a very nice variable. You don't have this expression as being squared. You have just this monomial here, u, that's being raised to the second power. So you have this quadratic equation that is in standard form, and the ones we're dealing with will be factorable, but if you have difficulty factoring this, you could always use the quadratic formula. But this is factorable, and so when you factor this, you're going to get 4u, so 4u times u is 4u squared. Some of you are going to try 2u and 2u, but that's not going to work, so don't even attempt 2u and 2u for the same reason that that last term here is a negative 4. And the only possibilities of negative 4 are 2 times 2 and 4 times 1. And so if this is 2 and this is 2, it will never work. So the only thing that works here will be 4u and u, and then we're going to put the 4 here and the 1 there. So 4u times u is 4u squared. 1 times 4 is 4. Now we got to look at that sign, which is negative. That means that these signs in here are different. And the larger of the outer and the inner is going to take that middle sign here. And so that means that if I want this to be a positive 15u, then this will be plus and this will be minus. All right? And so that's how that works. Okay, and you always double check, always check, FOIL this out to make sure you get this back. All right, and then now we're going to use the zero factor property. And so remember, the zero factor property says if I have at least two factors whose product is 0, then one of them has to be 0, right? So I have 4u minus 1 equals 0, u plus 4 equals 0. And then you solve these two linear equations for the variable u. So I get 4u equals 1, and so u is 1/4. Over here, if I subtract 4 from both sides, I get u equals negative 4. All right, now these right here, these are the solutions to, see, the u is equal to these two numbers, right? So this is the variable u. So that's this equation here. But remember, my original equation had the variable x. So I've got to solve for x. So that's where I go back and resubstitute. So if this is u, so if u is 1/4, and I also say that u is equal to negative 4, then that means that 3x minus 4 has to equal to this and this as well. So you're going to resubstitute. So this becomes 3x minus 4 equals 1/4. And then same thing here, 3x minus 4 equals negative 4. Okay? And then we solve for x. All right, so I'm going to go ahead and add 4 to both sides, just like this. And some of you in class, you multiply both sides by 4 to get rid of the fraction. That's fine. So if you want to do that, that's well. Some of you have a little bit more difficulty adding fractions. So that's why you went ahead and just clear the fractions by multiplying by 4. And that's okay. But I'm going to just go ahead, since I started it this way, I'm going to go ahead and finish it. So when you combine like terms, negative 4 and 4 is 0. So you get 3x equal. Now 1/4, so you got to remember 1/4 plus 4. So 1/4 plus 4, which is 4 divided by 1. So you got to find the least common denominator, which is 4, right? So you're going to write two equivalent fractions whose denominator is 4. Well, these 1/4 is always equivalent to itself, right? Okay, now 4 is equivalent to what number divided by 4? So this is a 1, I want it to become a 4. So you're going to say times 4 times 4. So what you do to the denominator, you have to do to the numerator. So 4 is equivalent, 4 times 4 is 16, is equivalent to 16, and 4 times 1 is 4. So 4 is equivalent to 16/4. So now I have two fractions whose denominators are the same. So now I just add the numerators. So 1 plus 16 is 17. So 1/4 plus 16/4 is 17/4. And that goes here. Okay, so 17/4. But then you got to remember, all right, now I've got to get x by itself. So then I have to divide both sides by 3. So I get this right here. I'm just going to go ahead and rewrite it. So I'm going to divide both sides by 3. And so now when I reduce, I get 3 divided by 3 is 1. 1 times x is x. And I got to remember that when I divide fractions, see, when you divide fractions, a fraction divided by another fraction, we're going to change that division to multiplication. So I get 17/4 times, and the reciprocal of 3 is 1/3. So this, and I cannot reduce, but you would reduce if you can. So I get x equal 17 times 1 is 17, so you get 17, and 4 times 3 is 12. So you get 17/12. And if you want to write this, since this is an improper fraction, if you want to write this as a mixed number, you can. So it'll be 1 and 5/12. All right. Over here, when I add 4 to both sides, and I combine like terms, this is 0 and this is 0. Those are opposites. So when I add two terms that are opposites of each other, I get 0. But 3x and 0 is 3x equal, and this is 0. So to get x by itself, I divide both sides by 3. 3 divided by 3 is 1. 1 times x is x. So I get x to be, and then 0 divided by 3 is 0. And so those are the solutions to this original equation that had the variable x. And so your solutions are 17/12 and 0. All right, so that was number 8. Okay, now number 9. So let's look at number 9. So number 9. Okay, so number 9, you want to solve this following radical equation, which happens to be a square root equation. Now, when solving a radical equation, you'll notice that this is a square root. So the index right here is understood to be a 2. And so to solve for the variable x, which I have x in the radicand and x on the other side, so the variable x is on both sides. But to solve for the variable x, I need to first of all get rid of this radical. All right, so since the index is 2, right here, remember square root's 2, to get rid of that radical, I'm going to raise both sides to the second power. So you're going to raise both sides to a power equal to that index. But before you do that, you got to make sure that that radical is by itself, that radical expression is by itself, and it is. So at that point, then let me go ahead and rewrite this over. So at this point, I'm going to go ahead and square both sides. So you raise both sides to a power that's equal to the index. So since this is 2, I'm going to square both sides. If this was a 3 cube root, I would cube both sides, and so on. Okay? All right. Now, the next step is to notice this, that when you square a square root, the square and the square root undo each other. Those are inverses. And so basically what you have left is this radicand right here. And make sure you understand why that's the case. So let's look at a very simple example. So if I had the square root of x squared like this, right? So the square root of x squared means the square root of x times the square root of x. Well, the square root of x times the square root of x is the square root of x squared. Well, one of the properties you learned now assuming that x represents a positive number, one of the properties you learned is that you can rewrite a radical as an exponent. So this right here becomes this. Now look carefully. It becomes x raised. You can put this as a fraction. You can rewrite this as a rational exponent. The exponent divided by the index. So you have the exponent divided by the index. The index is 2. 2 divided by 2 is 1. So you get x to the first, which is x. And so the idea is that when you square a square root, they undo each other. So basically what you're left with is the radicand. And so you see that radicand here is what you ended up here. So basically what you have left then is 4x plus 9. All right, so that same idea. So basically you see where you had that square root of 4x plus 9 times itself, like this. All right, so mathematically this means the square root of, in parentheses, 4x plus 9 squared, because this times this is this squared. So writing this as a rational exponent, which is a something you learned in the past, a rational exponent, and you may have forgotten it, but always go back and review this rational exponent. That means I can write this as 4x plus 9, and then the exponent, so you're going to write a fraction. So the exponent will be this exponent here divided by the index. And it's always divided by the index, which is 2. 2 divided by 2 is 1, so you get 4x plus 9 to the first, which is just 4x plus 9. And that's what you're going to write here, 4x plus 9. So that's why we say the square and the square root undo each other. Those are inverse functions, because you just get the radicand, 4x plus 9. All right, so this right here may, for some of you, it's been a while since you've seen this, and you may have even forgotten that you ever did do this. But for what we're doing here, if you can just remember that the square and the square root undo each other and you're just left with the radicand, then you'll be fine. But it's a good idea to know why this is the case. And that goes back to the idea of writing radicals as rational exponents. That's why. Okay, so then we get equal, and now you got to go now and you're going to square this binomial. All right, so you're going to say, well, I'm going to write it out, x minus 3 times itself, right? And so when I FOIL, and you see it's a good idea to do this because what some students do when they're not careful, and then they end up with some issues, because I did tell you that these are going to be factorable, and so they're going to get an issue that if they're not careful, they're going to say this. They're going to say x minus 3 squared equals x squared plus 9. So that they generalize this right here to mean this squared and this squared. So x squared and then negative 3 squared is plus 9. But that's not true. Okay, that's not true. Whenever you square a binomial, you need to get a trinomial. So when you square a binomial, you will always get a trinomial. This is not a trinomial right here. That's a binomial. So squaring a binomial does not give you a binomial, it gives you a trinomial. So that's why it's a good idea to actually take the time, take this right here, rewrite what it means, and then FOIL. X times x is x squared. The outer, x times a negative 3 is a negative 3x. The inner, a negative 3 times x is a negative 3x. And we also talked about the fact that when you square a binomial, the outer and the inner will always be the same term. So if this is a negative 3x, this better be a negative 3x. And then the last, a negative 3 times a negative 3 is a positive 9. And so when I combine like terms, I get x squared. A negative 3x and a negative 3x is a negative 6x plus 9. So notice I go from a binomial squared to a trinomial. So x squared minus 6x plus 9. So just remember some of the mistakes that students make when they're not careful. So they'll write this, and then they're going to try and do all this work, and then they'll get stuck. And they got stuck because what they have here is not correct. Okay? So always know how to do things mathematically to get from one point to the next. Any error is going to affect your progress. Okay, so I have this quadratic equation now. So I went from a radical equation to a quadratic equation. And so I need to solve this quadratic equation. So I've got to put this in standard form. Well, the fact that x squared is on one side of the equation, on the right, and the fact that the coefficient of x squared is positive on this side, I'm going to bring everything else to this side. So I'm going to go ahead and basically subtract 4x from both sides. And remember, what you do to one side, you do to the other. So notice I'm also aligning my like terms. And I'm also going to subtract 9 from both sides. I kind of did two steps in one. And so when I do that and I combine like terms, 4x, when I do that, combine like terms, 4x minus 4x is 0. A negative 9 and a negative 9 is 0. So when I add those up, I get 0. Equal. So this side 0. Equal x squared. A negative 6x and a negative 4x is a negative 10x. A positive 9 and a negative 9 is 0. Okay, so just leave it like this now. Now I'm going to go ahead and transpose both sides. So remember, if a equal b, then b equals a, right? So 0 equals x squared minus 10x, then x squared minus 10x has to equal 0. Okay, now notice that you have two terms here, and you got to recognize that I can factor this left-hand side by noticing that the GCF, the greatest common factor of those two terms, is x. So I get x times x minus 10. So my GCF is x, so x times x is x squared. X times the negative 10 is a negative 10x equals 0. You got to make sure you say equals 0. Okay, so everything you write has to be mathematically correct. All right, and so now I'm going to use the zero factor property. I have two factors whose product is 0, so one of those has to be 0, right? So x equals 0. And then over here, x minus 10 equals 0. And so you solve for x. X is already by itself here. Over here, I have to add 10 to both sides to get x equal 10. All right, now, something else you got to remember. And then that's this. Whenever you raise both sides of an equation to an even power. So when you raise both sides of an equation to an even power, you must check your solutions. You must check the solutions. I'm going to call these the proposed solutions. Okay, you must check the proposed solutions in the original equation. All right, so these proposed solutions, 0 and 10, are solutions to this quadratic equation that we see here. Okay, so x equals 0, x equals 10 will make this equation true, this equation true, this equation true, this equation true. But the question is, are these solutions going to be solutions to this square root equation? And that's where you have to check, because in class, remember, we talked about the fact that when you raise both sides to an even power, it is possible you can introduce extraneous solutions. And so for us, we're just going to call those false solutions. Solutions that are solutions to one of these equations in the process, but not a solution to the original. All right, so we got to check both of those, and you have to check. I have to see that work. So if you all of a sudden do all of this, okay, and you say x equals 0, x equals 10, and you say the only solution is 10, and I don't see that work, how you know that that's the only solution? I cannot give you full credit. So take the time. It's not difficult. It only takes you 1 minute. Take the time to check this. So let's check x equals 0 in the original equation. So here's the original equation. Does not take a large amount of time. You want your points? Take the time. So if x equals 0, wherever we see the variable x, I'm going to substitute 0. So I get the square root of 4 times 0 plus 9 equal, and notice the question mark, I want to see that's equal to 0 minus 3. Well, 4 times 0 is 0. 0 plus 9 is 9, right? And so we have the square root of 9. But we know the square root of 9 is 3. Over here, though, I have 0 minus 3. or 0 subtract 3, which is a negative 3. And notice those are not equal to each other. So x equals 0, this is extraneous. So in other words, it's a solution to this quadratic, but it's not a solution to the square root equation that we had earlier. So you see, it only took maybe 30 seconds. Then we do x equal 10. So now let's check x equal 10. And so when we check x equal 10 in the original equation again, the square root of 4x plus 9 equal x minus 10. Where we see the variable x, I substitute 10. So I get the square root of 4 times, let me see, make sure, oh, I'm sorry, that's x minus 3, I'm sorry, I put x minus 10, x minus 3. Okay, so I get 4 times 10 plus 9, right? And I want to see if that's going to equal 10 minus 3. Okay, well, 4 times 10 is 40, right? 40 plus 9 is 49, so this is square root of 49. Square root of 49 we know is 7. What's 10 minus 3? 7. What do you notice about those two numbers? They're the same. So therefore, the only solution is x equal 10. So you're going to say the only solution is x equal 10. All right? So notice the checking. Make sure you do the check. If you want your points, do the check. All right, so I want to see that. So remember, when you raise both sides to even power, it is possible that you can introduce extraneous solutions, so false solutions, meaning that those proposed solutions you end up with here, 0 and 10, are solutions to something in the process. It's solutions to this quadratic equation, but it's not a solution to the original. All right, so that's number 9. Okay, let's look at number 10. All right, number 10. Okay, so number 10, we have this rational equation. And so we have an equation that's made up of rational expressions. And what's particular that I want you to notice is that at least one, in this case all of them, all of those denominators, all of those expressions in the denominator have a variable. And so the process I want you to use here is to multiply both sides by that least common denominator. So I want you to end up with a fraction along the way. Not a fraction, but I want you to end up with an equation where the denominators all have factors of 1. And so then once you get to that point, the rest of it is very easy. Okay, so that's the process I want you to use. That's the process I asked you to use. So now we got to find the least common denominator. Now if I'm going to find the least common denominator, I need to factor each of those denominators or each of those expressions rather, that's in the denominators. Well, x minus 1 is a linear factor. See x to the first, that's linear. It's a linear factor and the GCF of those two terms is 1. So there's nothing I can do here. Over here, same thing. The denominator here is a linear factor, x to the first, and the GCF is 1. Over here, though, that's a quadratic expression, and we're going to go ahead and factor this quadratic expression. Now, just a reminder, and that's not always the case, but just a reminder, if you're having trouble factoring this quadratic expression, just remember, usually, not always, but usually, the factors of this quadratic expression are going to be the factors that you see on the other side or in the other denominators. So if I see an x minus 1, then chances are one of my factors is x minus 1. If I see x minus 2, chances are the other factor is x minus 2. And it is, because look, if you check it, just to show you, if you check it, x minus 1 times x minus 2, x minus 1 times x minus 2, and you FOIL it, you'll get x times x is x squared. The outer is a negative 2x. The inner is a negative 1x. And the last, a negative 1 times a negative 2 is a positive 2. Combining like terms, I get x squared. A negative 2x and a negative 1x is a negative 3x. And then plus 2. Notice that is what you wanted. Okay? All right. So now we got to find the least common denominator. So remember, your least common denominator is a product of factors. A product. And it's a product of all these factors that you see in those denominators. So here's one of my denominators. Here's one of my factors, x minus 1. I have to have it. X minus 1 has to be part of my least common denominator. Here's the other one, x minus 2. I have to write it there as well. Remember, it's a product, so don't put a comma. If you put a comma, I cannot give you full credit because the least common denominator is a product of factors. So you must write as a product. You put a comma there, it's no longer written as a product. It's written as separate factors. Okay, the next one I see is an x minus 1. I already have it. Don't list it again. Do not list it again because then it's no longer a least. It's a common denominator but not a least, and then that's going to make things so much more difficult for you. The next factor you see is x minus 2. I already have it. So my least common denominator is just a product of these two linear factors. Now the next thing you're going to be asked to do is to find the restrictions, because remember, some of, in this case, all of them, all of my rational expressions contain variables in the denominator. So I got to find out what values of x will make those denominators 0. Because remember, you can never divide by 0. So that's undefined. So that's going to be my restrictions. So if I look at this, you're going to, and when you find your restriction, you're going to say that x cannot equal those numbers. So if you look at x minus 1, you're asking yourself, what value of x will make that denominator 0? That's what you're asking. Well, if x minus 1 is 0, then x is going to equal 1, right? So the value of x that makes this denominator 0 is when x is 1. 1 minus 1 is 0. So that's a restriction. Same thing here. X minus 2. So x minus 2 is equal 0 when x equals 2, right? So there's another restriction. So those are your two restrictions. And then you keep on going. You already found this one. X minus 1, same as this one. So that's going to be 1. X minus 2, same as this one. So that's going to be 2. So there's only two restrictions. Okay? All right. And now here's the work. Okay, so we're going to remember the process, and you have to use this. If you don't use this process, you're not going to get all your points, because that's the way I want you to do this. So you're going to take this least common denominator, and now you're going to multiply both sides by that denominator, by that least common denominator. Now notice on the left side there are two rational expressions, so put that in parentheses or brackets. X divided by x minus 1 minus 1 divided by x minus 2. So put that in brackets, equal, I'm just going to rewrite the left-hand side. And when you rewrite the left-hand side, write the denominator in factored form. Don't leave it as x squared minus 3x plus 2. Leave it in factored form. That's going to help you in a little while. Okay, so now we're going to multiply both sides by the least common denominator. So x minus 1 times x minus 2. So what you do to the left, you do to the right. X minus 1 times x minus 2. All right, now we're going to distribute. Okay, make sure you do this step. Some of you, and this is a mistake that you're going to make. Some of you want to right away forget about this right here. Forget about this. You want to go ahead and reduce this now. But be careful. When you reduce the x minus 1s, some of you make the mistake and only distribute the x minus 2, and that's incorrect. You have to multiply each of these by x minus 2. So do the distributive property first. So x minus 1, in other words, x minus 1, that's an x minus 1 here, times x minus 2 times that first fraction, minus, and then the LCD, x minus 1 times x minus 2 times that second fraction, equal. And since I'm running out of room, I'm going to go ahead and reduce these. And remember I said when writing this here, I always use the factored part, because you'll notice that these factors divide out. And remember, that's the whole purpose of multiplying by the LCD, right? Is to get this denominator to be a factor of 1, and it is. And the next thing you got to do is actually write the 1. So x minus 1 divided to itself is 1. X minus 1 divided by x minus 1 is 1. X minus 2 divided by x minus 2 is 1. X minus 2 divided by x minus 2 is 1. Okay? And notice 1 times 1 is 1. So all you're left with is this. 11, so 11 divided by 1 times 1 is 11. So all you get on the other side is 11. Okay, now let's go ahead and reduce this. X minus 1's divide out. Notice I put factors of 1. That's a good idea to do that. So I have 1. Now be careful on this side here. Let me go ahead and cover this part up. So be careful right here. Because I have 1 times a binomial times a monomial factor. So what I would do first is I would say, one, remember multiplication is commutative. So 1 times x is x, and so x is going to be multiplied by x minus 2. So I get x times x minus 2. Make sure you put that in parentheses, x minus 2. Okay, now over here we're going to divide out the x minus 2's. Now be careful. Um, be careful whenever you're subtracting a product like this. So subtracting a product. The way I would think about this is this. I have x minus 1 times 1 times 1, right? So let's do the monomial factors first. 1 times 1 is 1. So I'm going to put that 1 in front. So I'm going to say minus 1 times x minus 1. Make sure you write it like this. Otherwise, you're going to probably make an error. Equal 11. So now notice I went from a rational equation to an equation without any fractions. And this is just a quadratic equation now. And it's quadratic because when you multiply, when you distribute the x, you get x times x is x squared. X times a negative 2 is a negative 2x. A negative 1 times x is a negative x. A negative 1 times a negative 1 is a positive 1 equal 11. Combining like terms, I get x squared. A negative 2x and a negative x is a negative 3x plus 1 equal 11. So now notice I have this quadratic equation, but it's not in standard form, right? So I need 0 on this side. So let's go ahead and subtract 11 from both sides. Notice what you do to one side, you do to the other. You have to show this. So if you say subtract 11, then you have to say subtract 11 here. That's important because everything you write has to be mathematically correct. All right. So then x squared minus 3x, 1 and a negative 11 is a negative 10 equal, and 11 minus 11 is 0. And now let's go ahead and factor. So the ones you're going to have will be factorable. If you're having trouble factoring, use a quadratic formula. So the factors that's going to work here will be x minus 5 times x plus 2. So that's the factors that's going to work here. You can always check x times x, x squared. The outer is a positive 2x. The inner is a negative 5x. When I add them up, I do get negative 3x. And negative 5 times 2 is a negative 10. And I'm going to set each factor equal to 0. X minus 5 equals 0. X plus 2 equals 0 using the zero factor property. And then solving these two linear equations, I get x to be 5 and x to be negative 2. Now, those are your proposed solutions, right? Those are your proposed solutions. So remember, I'm solving a quadratic equation. Now I've got to check, I have to check if those solutions are solutions to the original, because the original was a rational equation. And all you have to do is look at those restrictions. So your restrictions are 1 and 2. Are any of these 1 and 2? And the answer is no. So both of those are your solutions. So the solutions are x equal 5 and x equal negative 2. So this rational equation has two solutions, 5 and negative 2. All right, so that was number 10. Okay, and then number 11. So let's look at number 11. In number 11, we have this problem. Number 11. Okay, so here's number 11. So you want to solve this inequality, and this happens to be a compound inequality, by the way. So that's a compound inequality. And what makes this particular inequality a compound inequality is the fact that you see more than one inequality symbol. Okay. All right. Now, to solve this compound inequality, when it looks like this, when it has this notation right here, when it looks like this, where you have on the outside you have real numbers, on the inside you have a variable expression. Okay, so when you have that compound inequality, the way you want to do this is to get the variable x in the middle. So once you get that variable x in the middle, then you'll be able to know what values of x will make this inequality true. So you're going to find all the values of x so that negative 7 is less than whatever that number is, and that number has to be less than 11. So what values of x will make negative 7 less than or equal to the eventual value you get, and that has to be less than 11. Okay? All right, so it's not easy to guess at this, so you have to do some mathematical work here. All right. So um, if if this was a simple linear equation, a simple I didn't mean equation, I mean inequality. If this was a simple inequality rather than a compound inequality, a simple inequality, then if this is all you had, then you know the first thing you have to do is subtract 2 from both sides, right? But remember though, we have 3 parts, so you have to subtract 2 from all parts. So make sure you say that negative. Subtract 2, subtract 2, subtract 2. From the left, the middle, and the right. A negative 7 and negative 2 is a negative 9. It's less than or equal to, this is 0. And you're left with a negative 3x, right? And then that's going to equal, and then 11 minus 2 is 9. Okay, now, if all I had was this, then you know that to solve this inequality, you would have to divide both sides by negative 3, right? To get x by itself, because right now you're multiplying by negative 3. The opposite of multiplying by negative 3 is to divide by negative 3. But remember, whenever you multiply or divide both sides of an inequality by negative number, you have to reverse the inequality symbol. So let me go ahead and rewrite this over. So again, whenever you multiply or divide both sides, either this or this, by a negative number, you have to reverse those inequality symbols. So at this point, I'm going to divide all parts by negative 3. Make sure you show the division. Divide, divide, divide. Okay? And say divide by negative 3, divide by negative 3, divide by negative 3. But the fact that I divided all parts by negative 3 means that this inequality symbol is no longer correct. So this becomes less than equal to becomes greater than equal to, less than becomes greater than. Okay? So make sure you change those. Those are no longer correct. So now I have negative 9 divided by negative 3 is a positive 3 is greater than or equal to negative 3 divided by negative 3 is 1. 1 times x is x is greater than, and then 9 divided by negative 3 is a negative 3. Okay? So what I want you to notice though is this, and let me go ahead and write it over here just well, let me go ahead and do it here since it'll be on the PDF part of this. So if you see this right here, you see this where you have x is greater than negative 3. All right, x is greater than negative 3. If I write it backwards, that also means that negative 3 is less than x, right? So x is greater than negative 3 means negative 3 is less than x. That's what that means when you write it backwards. Those are equivalent. Same thing here. If I have x is greater than or equal to 3, I'm sorry, if I have 3 is greater than or equal to x, then that also means that x has to be less than or equal to 3. That's what that means. Those are equivalent. And I'm making this point here because when you graph this, or when you write this as an interval in interval notation, which is what they asked you to do here, you need to write it from smallest to largest. But 3 is not the smallest. Negative 3 is the smallest. So you have to rewrite it backwards. So in other words, you're going to say negative 3. So if x is greater than negative 3, that means negative 3 is less than x. So negative 3 is less than x, and also x has to be less than or equal to 3, right? Okay. And so that is how you want to write this, so that way you don't make mistakes. So therefore, when you put this in interval notation, you're going from negative 3 to 3. Always go from smallest to largest. Your answer is not this. So don't put, this is incorrect. Don't put 3 to negative 3. So if you put this is not true. When you write interval notation, you always go from smallest to largest. 3 is not smaller than negative 3. All right? Now, okay, so that's why it's a good idea to do this. Okay, so now when we put in interval notation, so what I found is this. I found the solutions to this compound inequality I had earlier. This compound inequality. So any real number between negative 3 and 3, including 3, because remember the equal sign means 3 is a solution. This has no equal sign right here, right? Right here. No equal sign. So that means negative 3 is not a solution. But any real number between those. Now remember what real numbers are. So when some students look at this, they think like 2, um, 0, 1, -2. They think that those are the only solutions, but it's not. A real number could be decimals. For example, 2.87654 is a solution because that number is in here, isn't it? So there's an infinite number of solutions. So you can't list them all. You can't list them like we listed this. There's an infinite number of solutions. So what we do, since there's an infinite number of solutions, we can write the solutions in interval notation, or we can graph it. Now, in this case, I just asked for interval notation, so the answer you would have to give me is this. You have to say -3 in parentheses because there's no equal sign. -3 is not a solution, comma, and then +3 with a bracket because +3 is a solution. See that equal sign? So that's your interval notation. If you were to graph it, which you were not asked to do that, but if you were, your solutions, I'm going to put -3 and +3. Your solutions would be, and then you would need parentheses on -3, and then bracket on +3, and you would shade in every real number here. So when you're shading in all those real numbers, you're indicating that there's an infinite number of solutions. See, this number here is towards this area here. You could have -2.7 repeating, right? So -2.77777 and so on. That's on this side. So there's an infinite number of solutions. Now, someone else could have used, instead of parentheses and brackets, you could have said open circle, closed circle. So open circle corresponds to parentheses, closed circle corresponds to bracket, and then shade in. So either one's fine. Just make sure you know both of those. All right, so that is number 11. So that's going to take care of the problems 7 through 11 on solving equations and inequalities.